Okay, students, so you said question number 9, you didn't understand that day, right? So again, you see what it asks first thing. Let R be the relation on Z. So relation on Z means there is only one set they have given, right? So both set will be Z, Z. What is Z? Z is a set of integers, right? So this is your set, okay? So the relation is defined from this Z to this Z, okay? I will write down. Okay, now what is the relation? You can see in this relation, this is the element a comma b. Now a comma b must have some relation, right? So relation they have given. What is the relation between a and b? A minus b is an integer, means if I take these two elements, subtract, its result must be an integer. Okay, integer, all of you know, I guess, right? 0, 1 to all the whole numbers and negative natural numbers, all are your integers. Okay, so you can see in this set infinite elements will be there. 0, 1, 2, 3, 4 dot 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 5, 6, 7, 8, it will go on. Okay, here also 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, it will go on upside. Here also same. Okay, so they have asked you to find out domain. Now what was domain? Remember I said the first element of your relation set, collection of first element of your relation set. Okay, and what is your range? Range is those element which is having image. Okay, if I draw arrow diagram, this here, if this element is having image, then this element will belong to domain set. Okay, if this element is having image, those element which will have image here means relation with some element here, then those element, collection of all those element will be your domain. Okay, and those element which are image of this, okay, those will be in the range. You know that, right? Definition. So we will find out. We are not asked to find out to write down the relation set in roster form. Our aim is just to find out domain and range. And domain, we know that any element is having image, that element will be domain element. Okay, so I just have to find image of this one is there or not, image of this one is there or not, image of this one is there or not, this. Now in this way you cannot check for all element. It's impossible because infinite element are there, right? So you have to analyze from here only few numbers only, and you have to judge whether all this element, out of all this element, which element will have image here. Okay, which will be related. Remember arrow diagram. So see here, first I will check for this element one by one. All element you have to check, right, whether they are having image here or not. So see, I will check this one. 0, will it have any image here? You check how this element and this element must be related. Their subtraction must be integer, right? So if I take this and this element, suppose, okay, and I want to check whether these two element having that relation which is defined here or not. So 0 minus 0, what it will give? 0 only, right, which is integer. So if the two element from first set and second set, if their difference means if you subtract and if the result is integer, then that two element will be in the relation set. So here you will see 0 comma 0 will be there. Okay, next, now sorry, not domain element here, let me write in another page the relation set. That is rough work I am doing. Okay, let me write here only. Okay, this is your rough work. In your relation set, if you write in roster form, 0 comma 0 will be there. Why? Because you can see if I subtract this two element, it will be an integer. That's what the relation they have said, right? So in this set, all those elements will be there whose relation is what? Subtraction give you integer. If it give integer after subtracting, then that element will be here. Okay, so I know that this is related with this now. Okay, now this, is it related to 1? So to check that, 0 minus 1, how much you will get? Minus 1 again. So yes, this is related to this also, but I don't need this elements. Now 0 related to 2 also, but I don't need. Why? Because you have seen this is having image, means this element will be there in the domain. I just have to find that only, right? I have to find domain set only. Okay, I don't have to find this set. So rest whatever element is making, I don't need that. Why? Because this is having image here. So if this have image, then this will be there in the domain set. right? Next, let's check this one. 1, will it have image? Will it relate it to any set here? Obviously yes. If I subtract with this, it will give you integer, this integer. So if I have to draw arrow diagram, you know that this will be related to this, this will be related. Why? You can see 0 minus 2, it is also integer, right? So 0 comma 1, 0 comma minus 0 comma 2 dot 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 0 comma minus 1. So all integers here, 0 comma, all infinite integers will be there. Okay, I cannot write that one, infinite will be there, right? 0 comma 3 also will be there, 0 comma 4, 0 comma 5, all will be there. In this way, again 0 and negative 1 also will be related, 0 and minus 2 also will be related. You can check how they are related. Why I am saying they are related? Because if I subtract this and this, what you will get? 0 minus, oh here, 0 minus minus 3, what it is? So the difference between these two elements, minus minus plus, so it will be 3. So you can see 3 is an integer, so they are related. Okay, in this way this will be related to 4 also, 5 also, 6. It will be related to all element. Okay, here also all element it will be. Same way 1, will it related to any element or not? So in this way here infinite element will be there, 0 minus 5 all will be there. Okay, now not that only, you will have more element here. Now what are the next element? You can see, let's see whether, so 0 has having image here, right? So this element will be there in the domain set, because you can see first element we used to write in domain set, right? So first element is 0. Now this 0 we are not going to repeat here. Okay, only one time. Next, let's check whether 1 will have image or not. Obviously 1 also will have. You can check it is related to all element again, because if you subtract with any element, you will see it will give you integer only, because you know that integer, if you subtract with integer, the result always will be integer. Okay, so this, if you relate with anything, yes, it will be related to this, 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 it will go on. Okay, here also negative value also it will be related like this. Okay, all it will be related 1. So 1 is also having image, right? So 1 also will be there. So here 1 0 1 1 dot dot dot, then 1 minus 1, 1 minus. I hope you can understand now. In this way many elements. Now I don't need this set, I'm just explaining this one so that I can get domain and range. Okay, now range, I hope you already got the idea. All element here will be image of some element here, right? Every element you can check. If I take 1000, 1000 also will be related to 0. Why? Because 0 minus 1000 is what? Minus 1000. Minus 1000 is an integer, right? So even 1000 also will be image of something. So you can see, if you take any element, even if you take 1 lakh, 1 lakh also will be related to 0, because 0 minus 1 lakh, it will be 1 lakh only, that is minus 1 lakh, that is integer only, right? So all this element in this set will be image. So in range you can understand it will be 0 1 0 plus minus 1 plus minus 2 plus minus 3, all will be there, right? Both minus and plus, both element will be here. So in this way till infinite, which is nothing but set of integer. Okay, now in domain you can see 1 is related. What about 2? 2 also will be related, because I told you integer, if you subtract with any integer, you will get integer only. So you can see that 2 also will be related to all elements. What about 3? 3 also will be related to all elements. 4 also, 5. In this way negative numbers also. Minus 1, will it be related to 0 or not? Obviously yes. Minus 1 and 0, if you subtract, you will get minus 1 only, integer only, because I said integer minus integer will always give you integer only. You can check, you can verify yourself. Take any integer randomly and subtract with any integer, it will give you result integer only. So obviously this is integer and I am going to subtract with integers only, right? So if I subtract with any element here, obviously the result will be integer only. So this also will be related to every element. Okay, this also will be related. So you can see in this way all this element will have image or not. Obviously it will have image. You can see 0 is having image, 1 is having image too. How many, that does not matter. It is having image, so it will be there in the domain set. Okay, image means what? It is related to this, it is related. 1 will be related to something, 2 will be related to something. So all will be there. Plus minus 1, plus minus 2, plus minus 3, dot dot dot, it will go on. So this is nothing but set of integer only. Okay, now I hope it is clear. Still if you didn't understand, let me know. I will try another way also if it is there, okay? But I don't think that you will not understand like this. It's a very simple way to explain, okay? Through arrow diagram. So I have already explained. The only thing is you have to check between this element and any element here, it is related or not. If it is related, this will be your domain element and the image will be your range element. Okay, so you just check in that way, and the relation is very simple relation they have given. First, here whatever element you will select, and here whatever element you will select, both difference must be integer. So in that way you will see all this element here will have some image, and all the element here will be an image. Okay, so try to analyze whatever I have said. Don't simply just listen this. You have to analyze also whatever I have said here. Okay, then only you will understand all this. Clear? Okay, our next topic is function, which is very important for you. Okay, so one of the most important definition right now we are going to discuss. Now see here, definition, it's very simple, but student don't try to put more importance on all this definition. They simply try to practice exercise and want to get the answer. That's it. But try to understand this one, because this is, I told you, whatever we are studying now, we are making base for your class 12. Okay, so if you don't understand right now, then you will face problem in class 12. So from now onward, try to study these things hard and try to understand and clear everything whatever is there in the definition. Try to understand properly. Okay, now what is function? Now before discussing function, let me discuss a little bit more in your relation. Now see, when we have relation set, okay, A, B, C, suppose, okay, now if here suppose E, F, G, H, whatever elements are there, okay, so if I define one relation here, whatever relation, then what we used to do, one by one we used to check all this element is having relation with which element. One by one we used to check. So first element we have checked, suppose, and we have seen that A is related to E, suppose, okay, then it is possible that A can be belongs to related to F also, or A might be related to G also. Okay, next B is related to, suppose, F. It might relate to other element also, H. Just now we have seen, right? One example is this. Just now we have seen 0 is related to what? 0, because 0 minus 0 is integer. 0 is also related to 1. 0 is also related to 2. 0 is also related to 3. So you can see this 0 itself having how many image? Infinite number of images it is having. Right? This single element, it is having infinite number of image. Here also 1 also is having infinite number of image. Here is also infinite number. This also will have infinite number of image. This all will have infinite number of image. Okay, so here also you can see A is having how many image? 1, 2, 3 image. Okay, B is having how many image? 1, 2. C is having how many image? Let me draw 2 image, you can say, suppose. Okay, H and G. So every element is having more than one image, right? A is having 3 image, B 2, C 2, right? Now see what is function carefully. A relation F, there are relation I have said R, right? Now function is nothing but a relation only, means its element will be what kind? Same. In function also you will have element ordered pair only, and they will have some relation. Now see here, this is a special kind of relation again. See carefully. A relation F from set A to B is said to be function if every element, try to concentrate on this, every element of set A, this is your set A, this is your set B, suppose. So what they have said, a function is nothing but, it is a relation. We used to define function something like this in arrow diagram. Okay, function is defined from A to B. Now what is function? Function is nothing but relation, means this element and this element in the second side will have some relation. Okay, now what kind of relation? In which every element of set A, every element, okay, of set A has one and only one image in set B. Now see here, in case of relation, what you used to have, this element might have 3 image. This element might have two images, doesn't matter in relation, right? But when we discuss function, in function, first thing, every element, whatever element here you have, must have image. Okay, and how many image they have said? A, B, C, D, suppose. Okay, every element must have image first thing, and how many image? Exactly one image they must have. E, F, suppose, G, H. Here might be free element, no problem. H, I, J, whatever. Free element might be there in this set. But in this set, first thing, function, what it is? I told you it is relation. If it is relation, you know what is relation, right? Here, whatever elements are there, they might have some relation with this. They may be related. So in the relation set, you will write those ordered pair only which will have some relation, right? But when we write function set, obviously this will be relation. A and B element must have relation. But what kind of relation? Every element, first thing, from set A must have image. In relation, it can be like this also. A, B, C, D. This is E, F, G, H. This might have image. This might have image like this. This might have image here. But this may not have image. Does not matter in relation set, right? We have seen in Cartesian product, some element used to remain free also there. So, this first element may not have any image in relation set. Okay? But when we discuss function, in function, two condition is very important. What is that two condition? First thing, what you have to check, in your first set, every element is having image or not. You have to check that. Okay. Next, what you have to check, every element here is having how many image? They must have exactly one image. If it satisfies these two conditions, then that relation which you are defining, means where whatever set you will write down here, F I will write, okay, A, E, B, F, then C, G, okay, then D, H. This relation set, this is also relation set only, right? They are having relation. Now what is the relation here? You can see here first element will not repeat. Can you see? In case of relation set, you have seen, right, in previous example only, when I have to write down roster form here, what you got? 0, 0, then again 0 is related to something else, 1. Can you see? 0 is repeating. First element is repeating here. Okay? 0, 2 like this, 0, 3. First element is repeating. So when we draw arrow diagram, 0, 0 means what? 0 is related to 0, next 0 is related to 1, 0 is related to... So you can see this element itself is having how many image? Multiple image. This element itself is having multiple image, but in function it cannot happen. Okay, in function you must have element exactly one image. Each element here must have image first thing, because they have said, right, in the definition what it is. If every element of set A, every element of set A has one and only one image, exactly one image they must have. So when you are given some function, so you write down this one, okay, in your notebook. This you write down in your question. If they give you function something like this, x square plus 2, something like this function is given, suppose. Okay, this is relation only, right? Y is equal to x square something equation. I told you it is a relation only. Okay, so this relation is function or not, if you have to check. So what you have to check here? First thing, you have to find domain of this set. Okay, domain means every element here must have image, right? Element which is having image used to say to be domain element, right? All this element will be there in the domain. Now speciality of function. In relation, you can see here I have left free element, right? So this set A may not be domain set, because domain set will be what here? A, B, C only. This will be a domain in this set, because D is not there, right? Now A itself is not domain, you can see, right? Because this you cannot write A, because here D is not there, right? But in function, when we define function, we have seen every element of set A must have image. So every element is, if it is having image, means what? This set itself will be your domain. Okay, This first set itself will be your domain and this will be your codomain. This may not be range whole thing, because you can see free element can be there in the second set, no problem. But there should not be any free element in your first set, okay? Because according to definition, every element of set A has one and one image, has one and only one image. So every element must have exactly. It cannot have multiple image also. Okay, so to check function, always remember, first thing you check, first set is having, all element is having image or not, and how many image they are having, exactly one image or not. If it is satisfying these two condition, then we will say whatever function is given to you will be a whatever relation is given to you, that relation will be your function. Okay, so for example, we will take here say y is equal to x square. Okay, now I'm not mentioning x what to take, where from, I'm not mentioning means what, here x we used to take from here, right, from set this set, and y we used to take from this set. Now suppose I don't mention x what it will be, y what it will be, then you have to understand yourself. I told you, right, it is a set of real number. If they don't mention x what to take, y what to take, then remember the set will be real number, set of real number it will be. And set of real number, you know, right, it consists of all integers, also all rational, irrational number, everything will be there in this set. Okay, so see here in this case I want to find, suppose, whether this is this relation which is given to you, it's a function. Let me take simple example first. Let me take set here. If I take real number directly, you might find it complicated. Okay, let me give set here 1 2 3 4. Then set B I will write 1 4 6 9 16 20. Okay, now relation is given like this: a comma b dot a belongs to, what it will belong to, a, right, b belongs to b, suppose. Okay, and the relation defined as, suppose b is equal to a square. B is equal to a square is the relation. Means between a and b, what is the relation? B equal to a square. This equation is the relation. Okay. Okay. Now when I have to write down relation set, what I will get? Element. Here I will get b equal to a square, means I will check one by one, right here. Let me take another paper again. When I will write relation set, better draw arrow diagram. So see here, this is your set A, 1 2 3 4. This is your set B, 1 4 6 9 16 20. Okay, so when I have to write down relation set, how I will write? B relation is b equal to a square, means this element must be square of first element. B equal to a square means this element b must be square of first element, right? I hope you have understood why I'm saying first element, because a is from the first set, right? So this is its square of, one by one I will check. Okay, for every this element are having image or not. So 1 is square of any element here or not? Yes, this and this related, right? Okay, or if you want to reverse this definition also, you can reverse. Square you bring this side, what it will be? A will be square root of b. Okay, no, don't need to, because it will be plus minus, right? You might get confused again. Let me show you here only. So this is square of this, this is square of, okay, b is square of first element, right? You can see. What about 4? You can see 4 is square of this element, right? 4 is equal to 2 square. Yes or no? That is b, that is 4 is equal to 2 square. That is b, this is from the second set, right, only, is equal to a square, you can see, right? So this will be related. 6 is the square of any element here? No. 9 and 3. What about 16? Yes. Anything else? 16 will be square of 4, right? Yes. So you can see in this set I'm just giving you example, okay, just to explain you what is function, how to check function. So this two set is given to you and the relation is given. Now I have asked you check if R is function or not, because function is what? Function is relation only, right? But which kind of relation? A special kind of relation in which every element of set A has one and only one element. So I will write down this relation and we'll check this relation is function or not. This relation will be function when if every element here, first element is having exactly one image, okay, means first element should not repeat here. If it repeat, what you will understand, if it repeat means this is related to this is related to something else also, right? That is what repetition there means. So you can see all this element is having image, yes, and every element is having how many image? Exactly one image here, right? So this will be a function. Okay, just an example I have given, simple example. Okay, so based on this we will solve complicated question also. So try to concentrate first this definition well, then we will come back to the exercise. Now after this, this is not only function, there are some special type of function we are going to discuss. Okay, this is very simple function I have given, this relation, okay, b is equal to a square. Now we have more function which are very special kind of function, so we will define those function and we'll try to understand what are those functions in the next video. Okay.